let's integrate 1 over 1 minus tangent square x dx. How do we do this? I can see that the denominator has difference of square. So 1 is 1 square minus tangent square x. So I can write it like this. Integral of 1 over 1 square minus tangent square x dx. Now, I can rewrite this as integral of 1 over 1 minus 10x times 1 plus 10x dx. Okay, now you see this form here. What do you think you can do? Maybe you can try using partial fraction decomposition. So I'm going to let n equals to 10x here to make it easier. Okay, so now this here, this will become 1 over 1 minus, this is n, right? Times 1 plus, this is n. So like that. Since I'm using partial fraction decomposition, so I'm going to write this. That's equal to here 1 minus n plus 1 plus n. Now, since the exponent in each of this denominator is 1, so you just have a constant a and constant b here. Now we have to find out what a and b's are. Okay. To do that, let's find a common denominator for both of these terms. And to do that, we just multiply a by 1 plus n and multiply b by 1 minus n. So we have this. Is equal to a times 1 plus n plus b times 1 minus n, all divided by 1 minus n times 1 plus n. Okay. Now, since we have a common denominator on both sides, so we can say that the numerator equals to each other. So 1 equals to a times 1 plus n plus b times 1 minus n. 1 equals to, let's distribute. So that's a plus an plus b minus bn. Now group the right term. 1 is equal to here an minus bn plus a plus b. Now take out the coefficient. We have a minus b times n here plus a plus b, right? Group the right term. Okay, now since on the left side there's no n here, so a minus b must be equal to 0. So a minus b equal to 0. And on this side, a plus b is a constant, right? So it's equal to 1. So a plus b is equal to 1. Now, since a minus b equal to 0, that means a must be equal to b. Here, we can put b into a here. So b plus b is equal to 1. Now 2b is equal to 1. Then b is equal to 1 over 2. Now since a equals to b, so a is equal to here 1 over 2. So both a and b are equal to 1 over 2. So we can put it back here. 1 over 2 and 1 over 2. Now, here. So that is equal to 1 over 2 all over 1 minus n plus 1 over 2 all over 1 plus n. And we did say that n is equal to tangent x. So let's go back to the integral here. So integrating 1 over 1 minus 10x times 1 plus 10x Let me write here. It's the same as integrating 1 over 2 divided by here. N is tangent x, right? So 1 minus tan x plus 1 over 2 divided by 1 plus tan x here dx. And of course, I can break this down, right? So that will be integral of 1/2 over 1 minus tan x dx plus integral of 1/2 over 1 plus tan x dx. And of course, I can move the coefficient 1 over 2, the constant 1 over 2, out of the integral sign. So that is 1 over 2 integral 1 over 1 minus tangent x dx plus 1 over 2 times integral of 1 over 1 plus tangent x dx. Now, how do we integrate 1 over 1 minus tangent x and 1 over 1 plus tangent x? Okay, we can do this here. Half integral of 1 over 1 minus tangent x dx. Okay, so now let's rewrite the trigonometry identity here. That's equal to 1/2 integral of 1 over, we know that 1 minus tangent x is the same as sine x over cosine x dx. And that's the same as, let's rewrite this with the common denominator as this one here. So 1/2 integral of 1 over cosine x over cosine x minus sine x over cosine x dx. Now we can group this together. We have 1/2 integral of 1 over, that will be cosine x minus sine x all over cosine x dx. Now, it's the inverse of this, right? So it's equal to 1/2 integral of cosine x over cosine x minus sine x dx. Okay, now, how do we integrate this? It does not look like the U substitution method will work, right? But I can rewrite this integral to make it work. Okay, so here, integral of cosine of x. Now, if I subtract sine x, right? So this term here can cancel out this term easily. But since I subtract sine x, I have to add sine x here so that I don't change anything. Now, if I do that, right, if I only add sine x, I will just have another term of sine x over cosine x minus sine x. That will not work either, right? It's similar to this term here. So what I have to do is, maybe I have to add cosine of x here. Like that. Okay, if I do that, looking at this numerator here, overall, I have a total of 2 cosine x. But in the original integral, there's only 1 cosine x, right? So I have to multiply by 1 over 2 here, right? So that is not changed. Now, all divided by cosine x minus sine x dx. Now, so this integral here is exactly the same as this integral here. So I've not changed anything. Now, what can I do? Now I can break it up from here, right? So that is here, 1 over 4. Integral of here, cosine x minus sine x, all divided by here, cosine x minus sine x. Now, plus, right? This is plus. Plus sine x plus cosine x all over cosine x minus sine x. Now dx. Now notice that from here, right, the numerator and the denominator are not exactly the same. But if I want to use substitution, right, the derivative of cosine x is negative sine x, and the derivative of negative sine x is negative cosine x. So the signs here are not the same, right? They're opposite. But that would be easy change. All I need to do is change this one into minus, then I change all this into minus, then the minus and minus will cancel out to become plus, right? Okay, so now that is equal to 1 over 4 integral of cosine x minus sine x, all divided by here, cosine x minus sine x, minus, now what's the top here? Okay, let me just write cosine x first, right? So plus cosine x become minus cosine x. Plus sine x will become minus sine x. All divided by here, cosine x minus sine x dx. Then this will work. Okay, now let me rewrite this. That's equal to 1 over 4 integral of this cosine x minus sine x all over cosine x minus sine x dx. Now minus 1 over 4 integral of this, right? Negative cosine x minus sine x all divided by here, cosine x minus sine x dx. Okay, now this is just equal to 1. So that is 1 over 4 integral of 1 times dx is dx. Now minus this 1 over 4 integral of minus cosine x minus sine x all divided by cosine x minus sine x dx. Okay, now for this, let's use substitution method. Okay, so I will let u equals to the bottom. So u equals to cosine x minus sine x. Then what's du equal to? Du will be equal to, now, derivative of cosine x is negative sine x. And derivative of negative sine x is negative cosine x. Okay, so now times dx, right? So this can replace with this completely here. So this one here will become integral of 1 over u times du. Okay, that is just equal to ln of u. And u is equal to cosine x minus sine x. So that is ln of cosine x minus sine x. Okay, now this whole integral here is equal to, now, 1 over 4. Integral of dx is just x. So that is times x. Minus, so minus 1 over 4 times, right? This integral is ln of cosine x minus sine x. So that's ln of cosine x minus sine x. Okay, so we just did the integral for this. Now, we have to do the integral for the second one, which is this one here. 1 over 1 plus tangent x. Okay, let's do here. 1/2 integral of 1 over 1 plus tangent x dx. Now, same thing here. let's rewrite this trigonometry identity, and that's equal to 1/2 integral of 1 over, now 1 plus, this is sine x over cosine x, now dx, that's the same as 1/2 integral of, this one is cosine x over cosine x, 1 over cosine x over cosine x plus sine x over cosine x dx. This is the same as 1/2 integral of 1 over cosine x plus sine x, all divided by cosine x dx. And that is just the inverse of this. 1/2 integral of cosine x over cosine x plus sine x dx. Okay, now how do we integrate this? Now, similar to what we did just now, right? So we will do this. 1/2 times integral of, now cosine x. If I add sine x here, I can cancel out with this here easily. But since I add sine x here, I have to subtract sine x, right? Because I cannot change anything here. Now, if I subtract sine x, I would just have another term of sine x over cosine x plus sine x, which is not easy, like this term here. So what I can do is, I will add cosine x here, like that, right? Then I can have this portion divided by this portion. However, if you look at the numerator here right now, the net total is 2 cosine x, but the original integral is only 1 cosine x here. So I have to divide by 2, right? So multiply by 1 over 2. Now, all over this, cosine x plus sine x, now dx. Now, this integral here is the same as this integral, so I have not changed anything. Okay, now, here, this is 1 over 4 times integral of, here, cosine x plus sine x, all divided by this, cosine x plus sine x. Now, I will break it up here, okay? So, minus sine x minus cosine x here, right? Because minus become plus, right? All divided by cosine x plus sine x dx. Okay, so we can see that this is just equal to 1. How about this one here? Well, the issue here is, if I use u substitution, right? The derivative of sine x here is cosine x, and the derivative of cosine x is sine x here. Again, the signs are opposite, so I have to change this. I can easily change this. All I need to do is just multiply this numerator here by -1, right? To do that, I just have to net out the negative sign here to become plus, right? So this become plus. So then this become minus and this become plus. Okay, now it will work. Let's do it like that. So 1 over 4 integral of cosine x plus sine x, all divided by cosine x plus sine x dx plus, this is plus, right? 1 over 4 integral of this, negative sine x plus cosine x, all divided by cosine x plus sine x dx. Now, this is just equal to 1. So that is equal to 1 over 4 integral of 1 times dx is dx plus 1 over 4 integral of this, negative sine x plus cosine x, all divided by cosine x plus sine x dx. Now, How do we integrate this? We use the U substitution method. But since I have already used U before, so I'm going to use a different letter this time. Maybe I use K. So let's say I let K equals to this, right? Cosine X plus sine X. Then dk is equal to this will become negative sine X plus cosine X, right? That's a derivative times dx. Now I can replace this part here completely with this one here. So this integral will become integral of 1 over k dk. And that's just equal to ln of k. And k is equal to cosine x plus sine x. So this part here is equal to ln of cosine x plus sine x. Okay, now this integral will become 1 over 4 x plus 1 over 4 ln of cosine x plus sine x. This one here. Okay, so that is the integral of this one here. Now, what I need to do is just combine the integrals of what I just did for this, right? Okay, so that is equal to, what's the integral of this? It's this one here. One over 4 x minus 1 over 4 ln of cosine x minus sine x. Now plus, what's the integral of this? It is this that I just did. This one. One over 4x plus 1 over 4 ln of cosine x plus sine x. Okay, now look at this. We can combine the like terms, right? So 1 over 4x plus 1 over 4x is 2 over 4x, which is 1 over 2x. Now, minus 1 over 4 ln of cosine x minus sine x plus 1 over 4 ln of cosine x plus sine x, we can still combine this. Now, first of all, let's take out the 1 over 4 as a common factor, right? And that is here, ln of cosine of x minus sine x. Now, this is a plus, but I take out a negative 1 over 4, so this becomes minus. Okay? So minus ln of this one, cosine x plus sine x. Now, here, right, this one here, applying the property of natural log, we can rewrite this as, now 1 over 2x minus 1 over 4 ln of, here, cosine x minus sine x divided by here, cosine x plus sine x. Now, are we done? Yes, we are done. We can plus c here. So this is the integral of one over 1 minus tangent square x. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.